In Module 8, Section 2, we will learn how to solve systems of linear equations by the addition method. The addition method is based on the addition property of equality, where we added equal quantities on both sides of an equation, which resulted in an equivalent equation. Here are the steps for solving a system of two linear equations by the addition method. First, we rewrite each equation in standard form, x and y on the left side, constants on the right side. Then, if necessary, we will multiply one or both equations by a non-zero number so that the coefficients of a chosen variable in the system are opposites. Step 3, we add the two equations together. Step 4, find the value of the remaining variable by solving the equation that resulted from step 3. Step 5, we find the value of the second variable by substituting the value found in step 4 into either of the original equations. Then, as always, we can check the proposed solution in the original system of equations. Let's try an example. X plus y equals 7 and x minus y equals 9. Here we can see that the y value from the first equation has a coefficient of 1, and the y value from the second equation has a coefficient of -1. So they are already opposites. Because we have opposites in that variable, we can add each component of our equations together. That will give us 2x, y minus y is 0, the y's cancel, equals 7 plus 9 is 16. We then divide both sides by 2. The 2's on the left-hand side cancel, and we are left with x equals 8. Once we have a number value for one of our variables, we take that value into either of the original equations. I'll put it into the first equation. That gives us 8 plus y equals 7. We then subtract 8 from both sides of the equation. They cancel on the left-hand side, and we are left with y equals -1. Too many signs. We write this as an ordered pair, so we have 8, -1. Here's the second example, 6x minus 3y equals -3. 4x plus 5y equals -9. Now, right away, we do not have opposites in the x variable or the y variable. So we will have to multiply one or both equations in order to find that. Because the y variables have opposite signs, it may be best to go ahead and cancel those variables. It's not necessary. We could choose x or y. For this example, I will choose y. In order to create opposites for the coefficients, we need to find the least common multiple of 3 and 5. Hopefully you remember how to do that. The smallest number that 3 and 5 will multiply into is 15. So to get a -15 in the first equation, we will multiply every piece by 5. To get a +15 in the second equation, we will multiply every piece by 3. Doing so will give us two new equations with different coefficients. The first equation will become 30x minus 15y equals -18, -15. The second equation will become 12x plus 15y equals -27. Now that we have opposites in one variable, we add every component together. 30x plus 12 is 42x. The y's cancel because they are opposites. Equals, when we add the constants together, we get -42. We can now divide both sides by 42, leaving us with x equals -1. We take that value x equals -1 and plug it into either of the original equations. It doesn't matter which one. So let's plug it into the second equation. 4 times -1 plus 5y equals -9. That gives us -4 plus 5y equals -9. We then add 4 to both sides of the equation. And we have 5y equals -5. We now divide both sides by 5, and the answer is y equals -1 for that particular equation. Now that we have an x and a y value, remember we write that as an ordered pair, so we have -1, -1. In the next equation, or set of equations, we see that we have fractions. Let's talk about how to eliminate the fractions before we ever start trying to work the problem. For each equation, we need to find the least common denominator between the fractions that are present. So we can see in the first equation, we have a denominator of 3, 4, and 2. The least common denominator for 3, 4, and 2 will be 12. Because the least common denominator is 12, we want to multiply every term by 12. When we do so, this is what it looks like. So we have 12, we can write it as 12 over 1 times 2/3 x plus 12 over 1 times 1/4 y equals 12 over 1 times negative 3 over 2. As we multiply and reduce, this becomes 8x plus 3y equals negative 18. Now in the second equation, we only have two fractions, and the denominators are 2 and 4. The least common denominator between 2 and 4 is 4, so we will multiply both terms on the left-hand side as well as the term on the right-hand side by 4. And that will give us, if we rewrite it, 4 over 1 times 1/2 x minus 4 over 1 times 1/4 y equals 4 times negative 2. When we multiply the fractions and simplify, we're left with 2x minus y equals negative 8. Let's take each of these equations, write them on the next slide, and go through the process of the addition method. So our first equation was 8x plus 3y equals negative 18 after we multiplied both sides by the least common denominator. The second equation became 2x minus y equals negative 8. To get opposites, we already have opposite signs for our y variable, so we can multiply the second equation by 3. That gives us 6x minus 3y equals negative 24. The first equation stays the same, 8x plus 3y equals negative 18. Now that we have opposites, we add like components. So we have 14x, the y's cancel, equals negative 42. Divide both sides by 14, and we determine that x equals negative 3. Now we could take this value of x equals negative 3 and plug it back into the equations that contain fractions. But because our two new equations are equivalent equations, we don't have to go back to the fractional equations. So let's take this negative 3 and plug it into one of our two new equations. I'll use the second before we multiplied by 3. And that gives us 2 times negative 3 minus y equals negative 8, which becomes negative 6 minus y equals negative 8. We can then add 6 to both sides of the equation. We have negative y equals negative 2. So our last step, we divide both sides by negative 1, and we have y equals 2. Now that we have an x value and a y value, we write that as an ordered pair, negative 3, 2. In a similar fashion to what you found in the last section, the use of the addition method to combine two equations might lead you to results like 5 equals 5, which is always true. And anytime we have a solution that is always true, then we know that we have infinitely many solutions. Or we might have 0 equals 6, which is never true, and that indicates we have no solutions. So make sure you are mindful of that as well. It doesn't matter what method you are using, it's still possible to get infinitely many solutions or no solutions.